Welcome. Today is part 5 of the chapter binomial theorem. So, first problem is problem number 19 of that chapter, and it is in a minus b to the power n is greater than or equal to 5. The sum of fifth and sixth term is equal to 0. Then a by b, how much? Options: n minus 3 by 4, n minus 4 by 5, 5 by n minus 4, and 4 by n minus 3. Problem is, this is a binomial a minus b to the power n is a positive integer and n is greater than or equal to 5. In that case, given that its fifth term and sixth term, sum of the fifth and sixth term is 0, then a by b how much? So clearly t5 is equal to fifth term of that expansion. So nc4 a to the power n minus 4 and minus b to the power 4. T6 is equal to nc5. It is just one less than that, always. A to the power n minus 5 into minus b to the power 5. So we are given that their sum is 0. So we have nc4 a to the power n minus 4 into b to the power 4, because minus to the power 4 is positive, plus nc5 a to the power n minus 5 minus b to the power 5. So okay, minus b to the power 5 is equal to 0. That is nc4 a to the power n minus 4 b to the power 4 is equal to nc5 a to the power n minus 5 b to the power 5. So terms will cancel. Cancelling this and that, a to the power n minus 5 will be cancelled. So actually nc4 into a, and between this and that b will be there. So it is equal to nc5 b. So we must have a by b is equal to nc5 by nc4 is equal to factorial n by factorial 5 into factorial of n minus 5. By that, factorial n is there, factorial 4 and factorial n minus 4. This cancels. Between this and that, it is n minus 4 will be in numerator, and between this and that 5 is there. So a by b is n minus 4 by 5. So second option is correct. Next problem. Problem number 20. Problem number 20 is if ratio, problem number 20, if ratio of seventh term from and beginning and seventh term from end of cube root of 2 plus 1 by cube root of 3 to the power n is 1:6, then n is equal to 12, 11, 10 and 9 options. In that expansion, uh, given that its seventh term from the beginning and its seventh term from the end, this ratio is 1:6. Then n is how much? Now, one thing, seventh term from the end means seventh term uh, from the beginning of 1 by cube root of 3 plus cube root of 2 to the power n. These two are interchanged. So, seventh term from the end is seventh term from the beginning of that. Mind that. So, seventh term from the beginning of this is equal to NC6 into cube root of 2 to the power n minus 6 into 1 by cube root of 3 to the power 6. Seventh term from the beginning of that is to by seventh term from the end of that means seventh term from the beginning of that. It is equal to NC6 1 by cube root of 3 this to the power n minus 6 into cube root of 2 this to the power 6 is equal to 1 by 6. This is seventh term from the beginning of that, and this is seventh term from the end of that. From the end means from there. So this will be cancelled. It is 2 to the power n minus 6 by 3 into 3 to the power, this is minus 1 by 3 into 6, that is minus 2 by, they cancelled. It is 3 to the power minus n minus 6 by 3. This one, it is 1 upon that. So it is power is negative into 2 to the power 2 is equal to 1 by 6. That is, from there 2 to the power n by 3 minus 2, this is minus 2, and this is when taken a numerator, it is minus 2 by, here is 3 to the power, this is plus 2 minus n by 3, this is plus 2, 3 to the power plus 2 there is equal to 1 by 6. So that 2 to the power n by 3 minus 4 by 3 to the power minus n by 3 plus 4 is equal to 1 by 6. This power is just negative of that. So we have to find n. Oh, okay. Then this is this when taken numerator it will be plus. So 2 to the power this into 2 to the power same thing. So it is 2 into 3 to the power n by 3 minus 4 is equal to 1 by 6. So 6 to the power n by 3 minus 4 is equal to 6 to the power minus 1. So that n by 3 is equal to minus 1, uh, n by 3 minus 4 is equal to minus 1. That is, oh, n by 3, then it will be plus 4. This is equal to minus 1. So n by 3 is equal to minus 1 plus 4. So that it is equal to 3. So n is equal to 9. This option is correct. Next, problem number 21. Problem number 21. This problem is if an is equal to sigma r is equal to 0 to n 1 by ncr, then sigma of r is equal to 0 to n r by ncr, how much? Given this is equal to that, then what is its value? Options: n minus 1 by an, oh sorry, into n n by 2 an, n plus 1 an. Okay. Problem is an is equal to that this summation sum of n plus 1 terms. To find sum of this of n plus 1 terms. Now let p is equal to this one, which we have to find out. Summation of r is equal to 0 to n r by ncr is equal to summation of r is equal to 0 to n minus r. This is r. So I can write it as n minus r by ncr. Here you see n is constant, r is variable. It varies from 0, 1, 2, 3 up to n. So first term is n into sigma of 1 by ncr, n by that, minus sigma of r is equal to 0 to n minus r by ncr. This is 1 upon ncr sigma, this, it is equal to an. So it is n minus this one, sigma r is equal to 0 to n minus r by ncr. Now this thing, sigma n minus r ncr r from 0 to n is equal to, I expand it. First of all, we have to put r is equal to 0. So it is n by nc0 plus n minus 1 by nc nc1 plus nc2 by n by nc2 plus dot 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 last term, last but one term, we have to put r is equal to n minus 1. So this is n minus n minus 1. So this is 1 upon nc r is equal to n minus 1 plus, when I put n, this is 0, n minus n is 0 by that. I write one more term here before that. It is actually equal to uh, corresponding to r is equal to n minus 2. So it is n minus n minus 2, that is 2 there. 2 by nc n minus 2. This term is there, mind that. Then plus this. Now an, now this one, again, this one, that is which is p. P is that, this. So P, you see, is equal to, putting r is equal to 0, this is 0. Putting r is equal to 1, this is 1 by nc1. Then 2 by nc2 plus 3 by nc3. Last but one term will be when n is equal to n minus 1. So that it is equal to n minus 1 by nc n minus 1 plus last term is, putting r is equal to n, n by ncn. Now this term is equal to that term because it is n by nc0 is equal to nc n minus 0, that is this term is equal to that term. Now this is n minus 1 c by nc1. This nc1 is equal to ncn minus 1, that is this one. So first term is this, second term is that, third term is this, and in this way we will get this is equal to p. So this is equal, this one is equal to p. So we get p is equal to n an minus p. So 2p is equal to n into n. So p is equal to n an by 2. So this option is correct. Next problem, and problem, it is problem number 22. Problem number 22 is, if n is a positive integer, then the number 2 to the power 22, then 2 to the power 3n minus 7n minus 1 is divisible by greatest number is 21, 49, 33 and 35. So here this is a number depending on n. Uh, this value for all values of n, it is divisible by greatest number. Which one of the following greatest number? To get it, we arrange it in that way: 2 cube to the power n minus 7n minus 1, 8 to the power n minus 7n minus 1. It is equal to 1 plus 7 to the power n minus 7n minus 1 is equal to 1 plus nc1 into 7, that is n into 7, plus nc2 n minus 1 by 2 into 7 square. Then all terms, after that all terms are of the order 7 to the power 3. Means all terms are either 7 to the power 3 or more power of 7. Minus 7n minus 1. Now 7n cancel, 1 cancel. So it is equal to n minus 1 by 2, 7 square, plus numbers of the order 7 cube. Now mind that this is an integer, n minus 1 by 2. Two consecutive integers, one must be even, so 2 will be cancelled. So it is always divisible by 7 square, that is 49. So 49 is answer. Next, for 23, problem number 23. The coefficient of x to the power 20 in x plus 2 to the power n plus x plus 2 to the power n minus 1 into x plus 1 plus x plus 2 to the power n minus 2 into x plus 1 in whole square up to x plus 1 to the power n. Then in that problem we have to find coefficient of x to the power 20 in that expression. This is a binomial, this is product of two binomial and so on. The options. The options are nc20 2 to the power n minus 20. Second option, n plus 1 c 20 into 2 to the power n minus 19 minus 1. Next option is nc19 into 2 to the power 20, nc20 into 2 to the power 19. In that case, this is an expression containing few binomials. Then in that expression, to find what is coefficient of x to the power 20, we can get x to the power 20 from here, 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 everywhere. So to get that, from here, I take x plus 2 to the power n common. It is 1 plus. This is x plus 2 to the power n minus 1, but I have taken x plus 2 to the power n. So it is x plus 1 by x plus 2. From here, This is x plus 2 to the power n has taken common. So x plus 2 to the power 2 will be there in denominator. That is x plus 1 by x plus 2 whole square. This way x plus 1 by x plus 2 to the power n. Now clearly this is in GP, geometric progression. First term is 1 and common ratio is this. So it is equal to x plus 2 to the power n into 1 minus x plus 1 by x plus 2 to the power next higher term n plus 1 by 1 minus common ratio x plus 1 by x plus 2. This is equal to x plus 2 to the power n into x plus 2 to the power n plus 1 minus x plus 1 to the power n plus 1, and this is in denominator, that is 1 upon x plus 2 to the power n plus 1. So I have taken into account this thing by whole divided by, this is x plus 2 minus x minus 1 by, that is x plus 2 minus x minus 1 by x plus 2. This cancels. So this is 1 upon that. So this will be there. So this is equal to x plus 2 to the power n, and this is another one. So I have taken this and that, and this is actually in denominator x plus 2 to the power n plus 1 into x plus 2 to the power n plus 1 minus x plus 1 to the power n plus 1. Now these two cancels. So actually it is equal to x plus 2 to the power, this means 2 plus x to the power n plus 1 minus, this is again 1 plus x to the power n plus 1. From there we have to collect the coefficient of x to the power 20. X to the power 20 will be there and x to the power 20 also will be there. It is so coefficient of x to the power 20 is n plus 1 C20 into 2 to the power n plus 1 minus 20, that is n minus 19 minus. From there we can collect coefficient of x to the power 20. So it is equal to n plus 1 C20 into 1 to the power this difference. So our answer is n plus 1 C20 common 2 to the power n minus 19 minus 1. So this option is correct. Next, that is problem number 23. Problem number 23, na 4. Problem number 24. If x square plus x plus 1 is equal to 0, then the value of x plus 1 upon x whole square plus x square plus 1 by x square whole square plus x cube plus 1 by x cube whole square up to x to the power 33 plus 1 by x to the power 33 whole square. What is the value of that? Given that x square plus x plus 1 is equal to 0. Options. Options is 36, 33, 55, and 66. Now actually value of x is given. We can obtain it by solving this is equal to 0. Value of x can be obtained. Then using that value, what is the value of these terms? That is, there are 33 terms, binomial, 33 binomials there. Now solving this, it is equal to x is equal to -1 plus minus root over b square minus 4ac by 2a. It is equal to -1 plus minus root 3I by 2. It is minus half plus root 3 by 2I and one value, and other value is minus half minus root 3 by 2I. This is omega square. Omega and omega square are cube root of unity, and its properties are omega cube is equal to 1 and 1 plus omega square is equal to 0. Now, so we get x is equal to omega or omega square. Now, one more thing, if I take x is equal to omega, this is plus 1 upon omega means omega square. So, whether I take omega, value of x is omega or omega square, the value of that expression is same always. So, our result is the required value is omega plus 1 by omega, mind that it is omega square to the power 2 plus here it is omega square, it is 1 by omega to the power 4, which is nothing but omega, that to the power 2 plus this is 1, omega cube is 1, this is omega to the power 6 is again 1 to the power 2 plus it is x to the power 33 means omega to the power 33. So omega cube to the power 11, that is 1. This is also 1 to the power 2. So the value is, this is -1 to the power 2. This is again -1 to the power 2. This is 2 to the power 2. After every third term, it is 2 to the power 2, and all other terms are -1 to the power 2. So it is equal to -1 to the power 2 plus -1 to the power 2 plus 2 to the power 2 plus -1 to the power 2 minus 1 to the power 2 plus 2 to the power 2 and so on. Now it is equal to 1 plus 1 plus 4. This is 1 plus 1 plus 4. That is, alternately, after third term, value is 4. How many 4s will be there? Because there are 33 terms. 33 divided by 3 is 11. So 11 times there will be 4. And 22 times there is 1. So answer is 1 into 22 plus 4 into 11. That is 22 plus plus 44 is equal to 66 answer. So option D is correct. So all right, let us stop today, and I request you to like, share my video, and please subscribe if not yet subscribed. Thank you.